thermonuclear process. For fusion to work, the atoms have to be so hot that they are stripped from their electrons. This would make a plasma, where nuclei and electrons are free.
Nuclei are positively charged and repel each other, so to overcome this, the particles have to be going extremely fast, which means very hot. Which means they're very hot. Stars are so massive that their own pressure generates heat and squeezes the nuclei together, which creates heavier nuclei and releases energy in the process. Scientists hope to harness this energy release in the fusion reactor.
The brute force method is almost impossible to achieve on Earth.
Energy is the currency of our Earth. It powers our homes and helps grow our food. There are many ways for energy, like fossil fuels, sunlight, and splitting atoms. But to all three of those, there's a downside.
For example, fossil fuels contribute massive amounts of gas to the environment, solar panels don't work on cloudy days and in lots of parts of the world, and nuclear reactors produce massive amounts of toxic waste. However, if we build a sort of sun on Earth, a lot of our problems would be solved.
I am here with Cole White Robinson, and he is going to tell us the difference between two reactors.
Well, there's two different types of nuclear fusion reactors. There's a magnetic confinement reactor, which uses superconducting electromagnets cooled with liquid helium to within a few degrees of absolute zero. The second type, which is called the inertial confinement reactor, uses a pulsing of superpowered lasers to heat the surface of a pellet of fuel within a chamber, which essentially implodes it, making it extremely hot and dense enough for fusion.
Denise, and she's going to be talking about the pros about nuclear fusion.
The nuclear fusion is a much better alternative to any other energy source. There are no carbon emissions, so the only byproduct is helium, which does not affect or add to the atmospheric pollution. There is also an abundant amount of fuels. The supplies needed to make nuclear fusion is everywhere, and it's very easily found. It is also very energy efficient. 1 kilogram of fusion fuel gives off the same amount as 10 million grams of fossil fuels, resulting in a much more environmentally friendly way to get energy. There's also no long-lived radioactive waste. Unlike other nuclear energy, there is very little radioactive waste. The little plants that do become affected by radioactivity will be able to break down in around 100 years. Safety. Nuclear fusion is also much more safe than any other form of nuclear energy. Because it is in such small amounts, it will not result in any large nuclear accident. And finally, nuclear fusion has much more reliable power. Nuclear plants are able to produce large amounts of energy, but still be able to be done at a reasonable price.
Fusion energy is a $10 billion gamble, but if it pays off, it can mean nearly free energy for everyone on Earth for thousands of years.